Hey everyone, welcome to section 8.7, question 23. So here we're going to take a look at the benefits of diversification by comparing portfolio investment versus a individual asset investment. So in this case, our portfolio is comprised of asset M, N, and O. So we'll calculate the risk and return, and then we'll compare that risk and return to just asset M. So first, we need to calculate the expected return of investing equally in all three assets, M, N, and 0. I'm just going to move this out of here because we don't need this right away. And the first thing we need to do is pretty much, we need to figure out what is the average return, okay? And the reason why I use average is because we're investing equally, okay? So the average return of comparing in our boom economy. So if we have a high return in N, we have a low return in O, and we have sort of a medium return in M. So what's the average of all of those three? Okay. Now it is equally invested, but I just want to point out in other words, we're also taking the weight of each investment, but it's equal. So because there's three investments, we're taking a third of that weight. Okay. So either way, we'll show you, but ultimately, we're trying to find a weighted average, but since it's the same, it will be the same as a regular average. But again, so we're going to be adding that 12%, okay, and that's going to count for 33% of the average. Then we're going to look at our N asset, okay, which is a bit higher, but again, equally weighted. And then finally, we have a pretty low return with our 2%, and we also need to weight that 33%. Okay, so in other words, the average return is about 11% for the boom economy, which makes sense because you're looking at high, low, and this is kind of in the middle. Okay, now again, if we want to sort of compare, if we use our average formula, we should get the same number. Yes, looks good. Okay, so go ahead and do that for all three. Okay, so again, we just have our average returns. Okay, and we can use that average return, or I would think of it as expected state payout. Okay, so based off of the economic state, that's what we can expect. Okay, so we're just taking our average. Now, if we recall, we'll use our equation to actually calculate the expected payoff of the entire portfolio. Okay, we're going to use this. So in other words, we figured out the average returns, okay? But we have to sort of take in consideration how likely that probability of a boom economy is going to be. So in other words, we need to include that in our calculation, and that's why we have our formula here. So in other words, expected payoff, okay, is going to be that probability, okay? So that's the probability of that state, okay? So what's the likelihood of a normal economy? Well, it's 50%. And then we're going to multiply that by that payoff. So in the normal economy, we're looking, 9% return. Okay, so we can now take these numbers here. Okay, and we're going to multiply them together, and the sum will be our expected payoff. Okay, so we just multiply the return and basically the likelihood of it actually happening, and then we add them together to give our expected payoff for the entire portfolio. Okay, so imagine that's our expected portfolio return. In other words, what they're asking for. Okay, so if we invested equally, that's what we're going to be getting at. Now, just be mindful, they're asking for a percentage, so let's make sure we do have it in a percent. And they want 2 decimal spaces. So let's go ahead and put that in properly formatted. Okay, so next question is, so now we want to see it, we want to do the same calculation, but we're only using M is our asset. Okay, so again, we're comparing what happens when we invest in just one asset versus what happens if we invest in a portfolio. okay, with different rates and returns, or risks and returns, pardon me. So for M, okay, again, we need to know, well, we can take this actually, okay, so in M, we know, again, we don't need to do an average anymore. We're going to use these as our expected payouts, okay? And then we can take our probability again. So we know the probability, that doesn't change. Okay, and we're just going to compare it in terms of just one asset. Okay, so we can do the same. We can use that same equation. Okay, so we're going to take the product. Okay, again, the return versus how often, the likelihood of that actually occurring, and we take the sum, and we're looking about an 8% return. Okay, so a little bit lower return if we just invested in M alone. All right, so now we're going to take a look at the risk part. So this was the return. Now we're going to determine the risk. So we're going to go back to our portfolio calculations and figure out what happens if what's the risk associated to investing in the entire portfolio. Okay, and we're going to recall this formula here. Okay, so that's going to help us figure out, first we're going to figure out the variance, and that's going to help us obviously figure out the standard deviation. Okay, so let's start again with our portfolio. So this is a portfolio question. Okay, so in regards to our portfolio, we're going to go back and always apply it to our different states. So if you recall from the first part, we ultimately need to figure out what's our expected payout, okay, per state. Okay, so think of it as a situation and environment. So again, remember, those are our average for all three, okay? And we need to compare that to think of that as our individual payoff, okay, for each environment. And we have to compare that to our expected payoff. So that was the entire expected payoff of our portfolio. Okay, and we're going to use this number. And that's going to be constant. Now I'm just going to add a couple columns here just so we can see what's happening. Okay, so if you look at the formula, we have our expected state payout, which is our payoff. Okay, and state refers to the individual environment. We're going to subtract it from our expected portfolio return. Okay, so our sort of our overall return. Then we're going to take that difference and we're going to square or raise it to the power of 2. Okay, so square that difference. So I'm going to just have a column there for difference squared. Okay, so again, we're going to take, pardon me. We're going to take the difference and then we're going to multiply it by 2. Okay, and we can do that for each state. So once we have that, so that's kind of takes care of this part of the equation. Then we have to multiply by the probability of each state, the probability of occurring. Again, that's our probability. So look at the boom, the probability of that happening is 30% and so forth. Okay, so then we multiply our difference times our probability. And now the only thing we have to do, remember, this is the sum of all this. That's what's our variance. So we're going to get the sum of these three risks, if you will, and that's going to give us our variance. And then we just have to figure out our standard deviation by taking the square root Okay, so that is our square root. Or sorry, yes, that's the standard deviation. So in other words, that's our risk. That's what's associated with this portfolio. So, and let's make sure we have the correct percentages here. So we want our format. So we want 2%, and we want 2 decimal spaces. So it looks like 2.4% deviation. Okay. Well, and then of course now we want to figure out what is the risk or standard deviation of just M alone. So same format, except now we are comparing, we're just considering M by itself. So what if we just only invested in M? We didn't invest in any other assets. What would happen? So ultimately we're going to use the same same idea. The probability is not going to change. Okay, so we can go ahead. Again, it's still the same probability. Okay, now for the expected payout, well, we have it right here. Okay, so we knew again, if we're just taking a look at M alone, we know that 12% returns expected in the boom, 8% normal, and finally 2% in a recession. Okay, now the expected pardon me, we should change this. It's not a portfolio anymore. Let me just make that adjustment. So this is expected sort of M return, okay? This is still the payout per M, okay? We still have our difference squared, and this is still our probability. So in terms of our M return, well, we calculated that here, okay? So that was the return on M in all 3 states, regardless of the environment, okay? So we can go ahead and bring that down. And we'll do the same thing again. So the difference minus M squared. And again, we're going to multiply the 2. Okay, so our difference times our probability. Let's just write that down so we know difference squared times probability. We know where that number is coming from. Okay, and then our variance is going to be the sum of those products and square root is finally our standard deviation. Okay, and we want a percent. We want in 2 decimal spaces. Okay, so I'll plug that in. All right, so now we have some questions. So again, remember, we're comparing the 2 decisions, either to invest in the entire portfolio or just to invest in M as an asset alone. So what happens when we invest in the entire portfolio versus M alone? Well, let's take a look. So here, if we invest in the entire portfolio, that's our return. If we just invest in M, okay, that's our return. So Sally can benefit by increasing her return by, okay, so again, we're going to take the difference and see that looks like there is about a 0.6%. Now in this case they want 2 decimal spaces, so yes, I would probably going to look like it's about 0.6. Yeah, okay, so we know she's going to get a 0.6% increase, and not only will she get an increase, but it looks like, well, if we take a look at our risk, So again, what is the difference? Either way, absolute value, but we're just going to see the difference. So we're going to get an increase in our return, and we're going to get also a decrease in our risk. Therefore, you can see the benefits of diversification. All right, thanks for watching, and happy financing.